Hello, my name is Victor Mateivici, and I am a PhD student at the Electronic Visualization Lab at University of Illinois at Chicago. What I'm going to present you now is my project 4 for the visualization class. In this project, we had to not only to visualize data, but we actually had to collect the data that we were going to visualize. So the goal of the project was to pick any CTA train line of Chicago and follow a one-way ride and using any logging devices that at least log GPS, gyro, and accelerometer, log the ride, and then visualize it. So for the data recording, we actually use the blue line from UIC Halstead to Forest Park and then back. And as recording devices, we use our smartphones since they are pretty sophisticated and they do have all the sensors needed. So after we got the data and we did some data processing, then each one individually had to create a visualization, and I'm going to present you right now my approach. So as you can see, I've got a main window where you can see the map with a black line. You can see the path that the train has followed, while with black dots, black spheres, you can see the stations. The train is, I depict the train with a cube, and the cube is red when the train is moving, when the train is not in a station, while it is green, it turns green when it stops at a station. At any time, by looking at the window, if you look at the corners of the window, you can find useful information for the train. So for example, by looking at the top left corner, I can see how many people are on board. By looking at the top right corner, I can see the heading of the train, and the bottom left corner, I can see the name of the station, or if the train is moving, I can get a status saying moving. And by looking at the bottom right corner, I can see the timestamp for that location. One thing you may notice is that beneath this map that I can move around, zoom in and zoom out, I have a second map that is a top-down view, a top-down map. The reason why I have implemented this is that sometimes if you want to see something in detail and you zoom into the map, then you lose context and you do not know what's happening outside the area that you have zoomed in. So in this example right now, I can see two stations, I can see the path, I can see the train, but I have no idea in regards with the rest of the path where the train is. So by looking at the bottom map, I can immediately see where the train is, and I can see how many stations are left until UIC Halstead. When I move the slider, as you can see, the train not only gets updated into my main window, but as well into the bottom map, so I can always know where the train is. One other interesting thing that I wanted to visualize is I wanted to show how bumpy the ride was. So for that reason, I implemented a bird's eye camera that always follows the train. What a bird's eye camera is, it is a camera that is situated exactly on top of the train, so you can see the train and you can see its movements. So if I go ahead and press the play button, you can see the animation, and you can see in the bird's eye window the train and how it moves, and you can see that the ride, it is actually pretty bumpy and it moves a lot. For the gyro and accelerometer readings, there was no obvious way to do it, and VTK does not have didn't have any control that I could use to visualize them, so I created my own. For the gyro readings, I have those three boxes. Each box represents the rotation in degrees for each one of the axes. So the first box is the rotation in the y-axis, and that actually means that if you are sitting in the train and the train is heading and you're looking forward to the direction of the train, then you can feel that by how the train moves on the right and left. So how much the train tilts right and left. The second box is the rotation around the z-axis, and it's actually if the train is ascending or descending a hill. So right now it seems that the train is positioned in an ascending position, and the last box shows you its rotation around the y-axis, and it shows you if the train is doing a left turn or a right turn, regarding to its previous time step, of course. And as you can see right now, it seems that we've got an 80 degrees turn. For the accelerometer, again, I use boxes, but this time with arrows, so you can see the acceleration data for each axis. So in the bottom box, the arrow that shows left, it means that we've got an angular acceleration value that points leftwards in the y-axis, and we've got the arrow that points down. It shows us the acceleration values for the z-axis, so it means that it's like somebody's pushing the train into the ground, while the second box shows us whether the train is accelerating or it is braking. Some interesting findings that I found by using this visualization is that if we go ahead at the beginning of the ride and press the play button and monitor the whole ride, we can see that on most of the ride, for the y-axis, we've got acceleration values that point leftwards. Initially, I thought that this is probably an error. This is probably a sensor error. But then, when I looked more carefully, I saw that not only for the acceleration values, but also if you look at the gyro values, you will see that for the same axis, there is always a rotation to the right. So as you can see in this time step, we've got a left acceleration value of minus 0.17, and there is a rotation of 35 degrees. And if we think about it, when we are in a car and we take a left turn, then we will have an angular acceleration and velocity that points towards the center of the rotation, but the car is tilted the other way around. So as you can see, this is exactly what happens here. So while on the map it is not obvious, there is no, I cannot see a lot of left turns, it seems that either the train is always turning left, or maybe the tracks are positioned in a way that the train goes leftwards somehow. One other interesting finding is, actually expected finding, is that if we play back the animation, we will see that usually before a station, we've got the train is deaccelerating, so we've got, like in this time step, we've got an arrow pointing backwards, while immediately after the station we've got an arrow pointing forwards because the train is accelerating again. And finally, I have used from the Great Lakes Observing System the elevation data for this area. The resolution is not great, but one of the things we can see while the resolution is not great is that if you look closely at the path that the train follows, you will see that exactly below it there is like a trench. And if you actually go to the blue line and look at the train, they actually dug in order to put the blue line there, because the blue line is in the middle of the highway, so it is below the level of where the houses and everything else is. Please feel free to visit my website if you want to see more of my projects, and if you want to get more information for this project. And you are always welcome for suggestions, comments, either on my YouTube channel, or you can send me an email.